Okay, now we're going to do section S.5, which is the last part of stats. Understand and interpret confidence intervals and margin of error. The focus on this section is interpreting data rather than doing calculations. And the calculations in here are like calculate a percent and add some numbers. So the calculations themselves are very straightforward. Introduction part 1. Consider the question, what is the mean height of all the students in your school? Well, to find the actual correct answer to that, you would need to measure the height of every single student, in the school so that we could obtain the population mean In reality, we're much more likely to measure the height of a random sample of students. And use that to estimate the population mean using the sample mean. So we're going to take a sample and we're going to use that to estimate the population mean by using the sample mean. The question then arises, how confident are we that the sample mean and the population mean are the same? In reality, we can never be absolutely sure, but we can determine a range of values around the sample mean in which we're reasonably confident that the population mean is actually in there. So for example, the sample mean, if the sample mean for the heights is 173 centimeters, we can't be sure, we cannot be sure that that is the sample population, or that is the population mean, okay? But we would be reasonably confident that the mean height of all the students in the school is somewhere between 167 and 179 centimeters, right? It's in there somewhere, probably. And we would be very confident, oops, I should spell that right, confident, that the mean height of all the students in the school is between 162 and 184 centimeters. Why are you more confident that the population mean is between 162 and 184 than we are that it's between 167 and 179? Well, the range is bigger. Think about a bigger target. Okay, so if this is the mean, the sample mean that I get, I'm fairly sure. Let's pretend that was a circle centered around that. I'm fairly sure it's in that area, but I'm even more sure that it's in that area. Okay. The range of values from 167 to 179 centimeters is called an interval. There is definitely some new vocabulary in this section. The interval can also be written as 173 plus or minus 6 centimeters. And in this case, the 6 centimeters is the margin of error. And you've probably heard those phrases comes up a lot in political surveys or any other sort of surveys. We'll see examples of that coming up. The range of values from 162 to 184 is also an interval. It can also be written as 175 plus or minus 11 centimeters. In this case, the margin of error is 11 centimeters. The level of confidence we have in the population, that the population mean lies in a particular interval, is called the confidence level. And the interval is then known as a confidence interval. So the confidence interval is the range of numbers we think it's between, And the confidence level is how sure are we that it's actually in there. Okay? All right, let's go to the next page. Introduction Part 2. Consider the question, what % of Canadian voters would vote for the Conservative Party? It's obviously impractical to survey the entire population of Canadian voters, so a sample is surveyed instead. A polling organization conducted an opinion poll whose aim is to determine the percentage of Canadian voters who would vote for the Conservative Party. They released the following statement. In the poll, 38% of Canadian voters said they would vote for the Conservative Party. The results are accurate to within 3.5 percentage points, 19 times out of 20. There's a lot of numbers in there. So the sample proportion, 38%, is an estimate of the true proportion of voters that would vote for the Conservative Party. So that's an estimate of the true proportion. So that was their sample mean, or sample, yeah, their sample, the number they got from the sample, 38% they would. The margin of error is the possible difference between the sample estimate, which is 38%, and the true value for the population, which we don't actually know. In this case, the margin of error is plus or minus 3.5%. And the confidence interval is the interval in which the true population proportion is estimated to lie based on the results of the sample. In this case, the confidence interval is our 38% plus or minus the margin of error, which is 3.5%, or ranging from, if we take the 38 and subtract 3.5%, we get 34.5%. And if we add these two numbers, we get 41.5%. Okay, so the 38% is our estimate of the true proportion of voters who would vote for the party. The margin of error is 3.5%. The confidence interval is that 38% plus or minus the margin of error. Okay? And the confidence level is the likelihood that the true proportion lies within the range of the confidence interval. In this case, it's 19 out of 20, which equals 95%. This means that if the survey were repeated over and over again, 95% of the time, the result would fall within the confidence interval given, so it would fall between the 34.5 and the 41.5% that we said was our confidence interval. Okay? Hopefully that makes sense. And if maybe you should make up some flashcards at this point to get that terminology right. Okay? All right, let's do an example. A golf ball factory did some sampling and made the following statement. The mean mass of golf balls produced at our factory is 45.6 grams plus or minus 3 grams. The results are accurate 19 times out of 20. So what is the confidence level? Confidence level is how sure are we about this, so it's 19 out of 20, which is 95%. And you'll find that's a really common confidence level. Determine the confidence interval. So it's going to be 45.6 minus 0.3 to 45.6 plus 0.3. So it's going to be 45.3 grams to 45.9 grams. That's our confidence interval. The margin of error is 0.3 grams. Okay, is it likely that the mean mass of golf balls produced at this factory is 45.1 grams. Well, 45.1 is outside our confidence interval. So is it likely? No. And I'm going to put more of an explanation here. There is only a 5% chance that the mean mass is outside the confidence interval. Okay, that's the 95 mind. We're 95% sure. 95% of the time it's in between it's within our confidence interval. So 5 times it's out. So no, it's not likely that it's there. There is only a 5% chance that the mean is outside the confidence interval. Is it possible that the mean mass of golf balls produced at this factory is 45.1 grams? Yes, that is possible. The probability of the mean mass falling outside the confidence interval is non-zero. So I'm just going to write that down. Okay. All right. Let's go on to the next section. Section 5.3, the effect of sample size on margin of error and the confidence interval. This is kind of like, why do we care about these things? The 2011 Canadian federal election took place on May 2nd, 2011. A large number of opinion polls were conducted in the days leading up to the election. The table below gives the results of 4 of these polls. And if you want to look it up, there's a link to the data. The data represents the percent of the sample who would cast their vote for each party. Some of the results don't add up to 100% because votes for minor parties and independents were not included in the table. The results are accurate to the stated margin of error, which is different for each. You can see it's different for each poll, 19 times out of 20. So let's look at the columns for the sample size and the margin of error. So we've got a sample size of 1,011 and a margin of error is 3.1%. We've got a sample size of 2,197 with a smaller sample size. Can you see that the larger the sample size, the smaller the margin of error? And that makes sense, right? Because if, think about the school example, the heights of people. If you measured half the people in the school, measured their heights, you probably are going to get you're more confident, you're more sure about your answer, your zone is smaller than if you sampled 20 people, right? For each polling firm, calculate the 95% confidence interval for the percent of Canadian voters who would vote for the New Democratic Party and complete the table. How does the sample size affect the range of values in the confidence interval? Okay, I'm just trying to get this to where I can see. This is not working. Okay. Oh, there we go. Okay. So the confidence, this column here shows the calculations. So I'm going to do Harris Decima first. So I'm just going to highlight that so we can see what we're looking at. Actually, we don't need all of that, do we? We just need the 30% and the margin of error. So the lower bound of our confidence interval is going to be 30 minus 3.1, and the upper bound is going to be 30 plus 3.1. So we're going to have it as 26.9% to 31.3%. Okay. For Angus Reid, we've got 33% plus or minus 2%. So we have 33 minus 2.2 to 33 plus 2.2. Oops, 2. Okay, and that gets us 30.8 to 35.2%. Okay, pause the video and go and do the next two calculations just to check that you're getting this right. Okay. Okay, there are the calculations. Maybe pause the video again just to make sure you got the same numbers as me, and then we'll go on to the last or the next page. Sorry. All right, for each polling firm, calculate the 95% confidence interval for the percent of Canadian voters who would vote for the Conservative Party and complete the table below. So you're just doing the same thing for the Conservative Party and the NDP Party. All right, pause it, do the calculations, and come back and check. There's no table for doing the or no column for doing the calculations this time because you know how to do them now. Okay. Okay. Hopefully you got all of those right. Question A. In which of the polls is there no overlap of percents in the confidence intervals? So that's asking which one is there no overlap in the numbers? So that would be in the NANOS research. So let's just highlight that one, the NANOS research. Oops, highlight. So the highest of our range for the NDP is 33.6, and then the Conservative starts at 34.0, so there's no overlap. If we look at the Angus Reid, this goes from 30.8 to 35.2, and this one starts at 34.8, so there's overlap there. Okay, so for this one, the answer is NANOS research. And this is important, I just wrote it out for you so you didn't have to. In this case, since there's no overlap, we can say with 95% confidence that the percent of Canadian voters who will vote Conservative is greater than the percent of Canadian voters who will vote NDP. So we can't say that in any of the other cases because there's overlap, and the number could be anywhere. For example, for Harris Decimal, the number could be 33.0% are going to vote for NDP and 32% are going to vote for Conservative, right? Because those numbers are within the respective intervals. So the only one where we can say there's a 95% confidence that more people are going to vote Conservative than NDP is the NANOS research. Okay. Question part B says, in which of the polls is there an overlap of percent? So it's actually all the other ones. So that's going to be Harris Decima, Angus Reid, and ECOS research. And from all of their polling, because there is an overlap, we cannot say with 95% confidence that the percent of Canadian voters who will vote Conservative is greater than the percent of Canadians who will vote NDP. In which of the polls can we say with 95% confidence that the NDP will receive a higher percent of the vote than the Liberal Party? Oh, you have to go back and do the calculations, and I'm not actually going to go ask you to do that. Let's just go back and look at this. Yeah, you'd have to do the calculations and compare it again, and I'm not going to ask you to do that because that's just really tedious. But all of the polls suggest, if you feel like checking it out, all of the polls. Okay, so make sure that you've written that down because that is the answer that I will be looking for if this question's on a quiz or a test. And oh, there is, sorry, there's another section. I thought we were done. Oops. Section 5.4, effective sample size on confidence level. All right, we saw that we saw earlier that a larger sample size leads to a smaller margin of error and therefore a smaller confidence interval. And similarly, a larger sample size leads to a higher confidence level. So the bigger the sample is, our confidence in that becomes higher. Okay, so let's return to the question, what's the mean height of all the students in your school? If you wanted to be 100% confident about the results, you'd need to measure the height of every student in the school. Probably not going to do that. Suppose the sample mean for the heights of students was, this is for a sample, 173 plus or minus 6 centimeters. If our sample was more than half of the students in the school, our level of confidence in that number, that the true value, the true mean lies within that confidence interval, it would be very high, okay, well above 99%. And there are actually, there are tables that tell you how this works. We're not going to get into doing these calculations. It's beyond the scope of this class, but it's fairly complicated. Okay, going back to the school sample. If our sample was about 1/4 of the students, our level of confidence that the true mean is it within that confidence interval would be very high, but not as high. And if our sample had only been a few students, our level of confidence wouldn't be very high, right? Because we've only looked at a few samples. That makes sense? Okay. But like I said, you're not going to be asked to calculate that. You just need to show that you understand that as the number of samples goes up, your confidence in that gets higher. Or you can get the confidence interval gets smaller. It's like you do one or the other. Example 1. A company produces hockey pucks. The league regulations state that the mass of a puck used in a game must be between 164 grams and 170 grams. The production equipment is set to produce pucks with a mean mass of 167.0 grams, and the standard deviation is calculated to be 1.1 grams. Quality control testing is done on a regular basis to determine if the pucks are produced to meet the required standard. To ensure that only a small number of pucks are rejected, the quality manager must ensure that the mean mass of pucks lies within the range of 166.7 and 167.3 grams. During each day, a random sample of pucks is selected and weighed. The table gives the sample sizes needed for different confidence intervals. Okay, so this is saying that if we want to have a confidence interval of 99%, we need a sample size of 89. Down to, if we want a confidence interval of 90%, we only need a sample size of 36. State the confidence interval the company is using for its quality control tests. So the confidence interval is the quality control manager must ensure that the pucks lie within this. So this is the interval that they're requiring. So it's 166.7 to 167.3 grams. State the margin of error the company is using. Well, remember the margin of error was some number x plus or minus the margin of error. So what we're going to do is take the difference between this. It's 167.3 minus 166.7 and divide that by 2. Okay, and that equals 0.3 grams. Okay, if you want to think about how that makes sense, if we took the average of these two, the average of those, let me just do that calculation, 166.7 plus 167.3, I could have done that, divided by 2. So the average of the middle of our confidence interval is 167. So 167 plus 0.3 equals 167.3, and 167 minus 0.3 is 166.7. Okay, so that's where the 0.3 is our margin of error, but we can just get it by subtracting them and dividing it by 2. Okay. How many pucks should be weighed in each sample if the company wants to ensure that the mean mass is within our confidence interval 49 times out of 50? So 49 out of 50 equals 98%. So we go up to our table and we look for 98%, and our answer is 73 pucks. Okay, and we got that from the table. All right. Pucks which do not satisfy the league regulations can be used in practice. How many pucks should be weighed if the company wants to ensure that the mean mass in the range, the confidence interval, 9 times out of 10? Well, 9 out of 10 is 90%. So we're going to go to our table and look up 90% in the table. So that's right there. So it's 36. So 36 pucks. Okay. And question E, if the company were willing to accept a mean mass in the range of 166.6 to 167.4, would they need to test more or fewer pucks in the table in order to attain the same confidence interval? Well, we're making our interval bigger, so if the interval's bigger, we need fewer pucks. Okay? So that's our answer, is fewer pucks, smaller sample size, gives wider interval. For the same confidence level. Okay. Okay. Now we're on the last page. All right, let's do example 2. Use confidence intervals to interpret the following statement. A recent survey showed that Canadian high school students spend an average of 1.5 hours per day accessing the internet and an average of 1.75 hours per day being physically active. The results are considered accurate to within 0.2 hours, 24 times out of 25. Now, obviously, this is an old survey before smartphones existed, because there's no way you guys spend only an average of an hour and a half per day on the internet. Neither do I. There's a format that we follow for the answer for this, but before we do that, there are a couple of calculations that we need to do. So I'm going to use the red pen for the internet numbers. So internet. And we're given the mean and the error of margin of error. So we're going to figure out what our confidence interval is. So we have 1.50 minus 0.2, which is 1.3, and 1.50 plus 0.2, which is 1.7. I guess 1.70, 1.30, because it was to 2 decimal places in the question. And the blue ink for active. And the average for that was 1.75. So 1.75 minus 0.2 equals 1.55. 1.75 plus 0.2 is 1.95. And then the other calculation, which I'll do in green, is converting the 24 out of 25 into a percent, and that's 96%. And then the answer that we are going to write out, I'm going to read it first and then I'll write it out. It can be said with 96% certainty that Canadian high school students spend between 1.3 and 1.7 hours accessing the internet, and spend between 1.55 and 1.95 hours being physically active each day on average. Oh, that's a lot. I'm going to cheat and I'm going to type it. That way you can read it better. So it can be said with 96% certainty that Canadian high school students spend between 1.30 and 1.70 hours accessing the internet, and spend between 1.55 and 1.75 or 95 hours being physically active each day on average. All right. And yes, you do need to write that entire thing out. That is the answer. All right. Okay, that's it. Go do your homework and then write a quiz. Bye.